I'm not sure if I find a single problem actually. No. No.
Okay, so you want to focus on, what was it?
I was just saying that for later, but right now, while I have her book, I wanted to find a problem that was on like net ionic and
Spectator ions.
Yeah, there we go.
Okay.
Problem 4.39 is a good one.
Complete the following acid-base reactions with balanced molecular total ionic. Very good problem. Write that stuff down real quick.
Is it okay if I scoot this over a little bit?
Huh?
Is it okay if I scoot this
Oh,
over
yeah.
a little bit?
Acid. I'm just writing these down so I can refer
Sure.
back real quick.
Okay, so they want me to just start by writing that equation over, like the reactions.
Oh, yes. Yeah. If you're showing
You can
work
keep
for
that.
this.
Sure.
Yeah, I got this now.
But anyway, first off, I have to know how to even write these down. So, cesium, I don't know cesiums.
Okay.
It says in the front of the book, it has all the elements and what the symbol is.
Okay.
Excellent is the heaviest.
It should.
Yeah, just it has the same exact thing.
You know, that page was taken out.
Why people were.
Oh, no, there it is. Here, turn one more. I think it's that one.
Okay.
You don't have to actually write it out, but can you tell me what the net ionic equation would be for
CS.
Because it's kind of helpful to imagine.
Cesium.
Separating them all
Hydroxide.
Like,
you have how many steps?
OH, right?
Because in your Greek system, there's all steps.
That's a
Spectator
negative.
yeah, so you'd have to separate everything all out and then cross out the spectator ions.
And then with those, I only do this side, or do I do both? Because I don't remember what you said.
To do, I guess,
CS.
you don't have to work through this. I was just pointing out that, like, what happens is that
And
you're
that'd be
going
a
to get
plus
H
one.
plus and Cl minus. Remember, you're
Okay,
gonna
so that's
get
already
H minus.
Balanced.
And over here, you
And then
have still
nitric
Na
acid.
plus and
That
Cl
I'm not
minus. So
familiar
really,
with.
the
We
Na
didn't talk
and
much
Cl are
about.
just
I just know
spectator
sulfuric
ions.
acid.
So
like,
the net reaction with this is just H plus OH
would be,
minus to water. It's really all you're making is water. So
like
then that'll be
HNO3 or
helpful
something like that,
later when
because
we're
you have
trying
to have the hydrogen for an acid, and
talk
I'm
about the
assuming
fact
it's
that this is
nitrate
1 to 1.
instead of
Yeah,
nitrite.
well, remember when they were talking about naming with polyatomic ions, there was one little section
guess you can
talking
see
about how to name acids with polyatomic ions. Like you're saying, if
it's
it
like
ended with
IC
something.
and OS,
Right.
like ferric and
So nitric would be.
So it'd be
So just be 0.
H,
Because they have it
and
starting
then
at a different point than 0.
nitric, so that'd be the smaller one.
So I would
It'd
just put
be
0.
um
Or that minus 0, right? Which would
2.
be whatever I got in the end,
like
19.5.
would it be NO2
Yeah, so you could just skip that step and
because
say
instead of
that
like
you used
NO3 because
exactly
it's
19.5
IC instead
mils
of
of
OUS.
Well, if
am I
it's
getting that
ic with an acid, what's the suffix for the ion?
IC with an acid.
Yeah, because there's a certain rule, like if it has one suffix, it's ic as an acid, and if it has another, it has another suffix. Do you remember that part in the book?
No, we didn't. We skimmed. That's another one of those things we skimmed because he thought that was common
We're
knowledge.
doing
Okay.
So honestly,
So-
that's all
for
I know.
HCl.
Is
Okay.
IC is smaller than
This
OUS.
is,
Yeah, so
Well,
I
this
would
is the
look
same
at the book to double check.
Alright.
it's just we
Oh,
use
they
19,
they got to their.
but first
Acid.
I'm trying to see, you may be
It
able
would
to
be
just,
sooner than that. It'd be
Oh,
like
geez, I
chapter.
didn't realize
or you do have to go to
Page
liters because
numbers.
we have to multiply this by, you're right, so So you just need your.
So then I multiply what I got by the given.
I vaguely remember writing
Well, because
something
you're.
about this
Well,
down
but
in my
first
notes.
to finish writing that, like it's 0.0195 liters of what?
Yeah, that's what I was doing all.
So it would be at the NaOH.
Yep. Because that's what we were dropping down. It said
And
here.
that's
the
really good to
theoretic.
practice, especially when the vocab kind of goes overlooked, especially with your professor assuming everything's common knowledge.
So if it has OUS, I had it flipped. If it has OUS, it is less charge. If it has IC, it has more charge. So, and that's table
There you go.
2.4.
Right.
Is that how he explained it to you?
Yeah.
Okay, because there is a different rule in the book. I mean, you could probably assume that too, but when you want to look at the name, there's another way to look at it.
Isn't ick 8? Like
Right.
nitrate, and us is ite.
Yeah.
And then so they changed it, just change it automatically to 2.
Yeah. I mean,
There it is.
he didn't tell you that, so that's not your fault.
Times
But
10 to the negative third.
That's not the right table.
I think it might be on the
I
next
don't think you
page.
should get to the end, really. You can do it now if scientific notation makes better sense to you. then
I
you can do
don't
that.
like is Sadly talking about that. Would they accept that?
They
This
should
is
accept
talking about
it.
8 and I and how like you per before or hypo before it. So it
Here,
just
look at the
am I-
next,
Oh geez.
right next to that. Yep.
Ick. So
And then I divide that.
uric acid. So if it
So the equation is now. So then you divide it by the liters given.
it's
And the
factor
problem
plus element plus
Well, what are we? What is the final thing we're trying to get? We're trying to get molarity HCl, which is what if I pick it apart? Like what? Go ahead.
Are you asking HCl?
Like what? No.
So 8
what
becomes
is
ick.
what is molarity HCl?
So that
What
means
does that
okay,
mean?
so it means it'd be nitrate, which would be NO3.
It's a different way of saying it.
Okay. And
Like what are the?
O3
Or
and
this is maybe a better way of saying it. What are the two components that I need to
NO3
figure
has
out
a
what
negative
molarity
negative 1
HCl
charge, and
is?
that has a positive 1 charge.
So
So
I need
Alright,
the
so
moles
negative.
of liters.
negative,
The moles of what?
positive.
Moles of
So to
or is it the-
Yes, we need to convert the moles of NaOH to moles of HCl
okay,
because
so
that's
the
eventually what we
CS
need. And we also need the liters
NO3 and
of
H2O.
So
the
then I
HCl
do-
solution.
Okay, so would that be the 50 since
CS
it's filled?
is a
Because that's what
positive,
they
and
did on
so
here.
that's
and
still
not-
all
I guess I
good.
don't get that. But they say
I'm not sure about the
H2O.
context of this, but like for this problem that we were given here, this is where
So
the HCl
now
is. This is where
it's
the
the ones that
NaOH is.
dissolve in
So what
water.
we're trying to find out is what was the concentration of the HCl.
We were
down
talking
in
about this.
before we ever
In
started.
fact, I think it
dropping
was
stuff
actually
down
you that
here.
asked the question.
So
What do
was
you
the
do with
initial
water
concentration
in
of the HCl?
like that kind of a solution? Like,
So what we
does
know
it
we
does
just
water
did,
dissolve in
like
water? Is I
forgetting
guess
about
what I'm
all this math
asking.
for a sec.
So you
What
just
we
leave H2O by
just
itself
did
instead
is
of
we neutralized all the
H2
HCl
plus
down
O.
in there by reacting exactly
Right,
as
and
many
it would
moles
have,
of NaOH from
like,
this
instead of
as there were
aqueous, it would
moles
have
of
its
HCl
own
down here. So what
label.
you
So,
just
like, separate
did is you did
category?
the math
Yeah.
to figure out how
And
many
what-
moles of
what is
NaOH you
water?
added, and because
Water's a
very
liquid, isn't it?
conveniently
Right.
it's a
Okay,
1-to-1
so-
ratio, we can know that
Liquid.
however many moles you drop down in are
And
how many
maybe put
moles
that
there
in
were down in
parentheses so
here
it
to
doesn't
begin
look
with.
like a 1 or something.
So then you have
Yeah.
moles of
Liquid.
HCl, and then
seasonal
once you
nitrate.
have moles HCl,
So
then what's the only other
H
thing
always
that you need
dissolves.
in order to get
So,
molarity? What do I have to put in
cesium.
liters.
liters?
So would I
And what
take that
is
10 milliliters and divide it by 1,000?
There you go. So you'll convert that 10 mils so that it ends up going there.
I think they.
And then you'll have
If
moles of HCl.
He also
liters
told
of
us like a
HCl,
trick
and
to remember,
you'll have
like if
everything
it
you
has
need.
like a -1 and a +1, like if it has low charges, it's more likely to dissociate. So is that? That wasn't a rule in the book, so I'm kind of leery
yeah,
on
that's
following
not a
it.
rule you can really depend on.
So
You needed to know the like the rules they give you in the book.
all right. So I don't remember
But-
talking about cesium, so I don't know if that's one of those except for with cesium type of
Yeah.
deals. But
Well, where is it on the periodic table?
group 1.
How you?
Yeah, and what,
Okay.
do you remember what
I don't
group
know how to
1,
figure
what the role is for
this
that one?
out.
Group 1, I think always dissociates.
How do I find the RM?
It's like,
that?
except if it's with like one other thing. I might be
So
mistaken.
then I looked up RMS.
I think I remember
I
it
don't know what that
does
stands for, to be honest.
I
dissociate.
think it stands
Alright, so you
If
get
you
I
want
know
to
I
double
learned it
check,
at some
I
point.
don't think it's that far in the
I
book,
think
but
it stands
if
for
you
root.
check my handy dandy Quizlet. Yeah, I've made 3 of them. Solubility rules. Solubility rules. All common compounds. Yep, are all soluble. So CS plus OH.
Oh, root means
oh,
what?
and don't forget
What it
your
stands
Okay.
Charges. Or-
oh, that too, but also what label do you also need to add in?
Explain to me what he was
equations
doing
like
with
this.
this.
Okay.
Like, you know
so
how
this
water's a liquid?
this is two
Okay, so you need to
different
put like aqueous next to the ones that will dissociate.
Right.
So
Substances.
I put
Okay.
and
AQ
As this-
next
Or
to
no,
that.
same gas, 2 different temperatures,
Plus,
right?
I believe, so
Isn't
that's
that what it
also
says?
aqueous because that fully
A
dissociates.
gas.
oh, at 2 different temperatures. See, I didn't get that
NO3
before.
plus
Oh, okay, so
negative.
that makes more sense because the behavior of a gas at a lower temperature.
I
Well,
feel like I
that
know it
is
already.
showing less.
CS
So what are our
plus
2 axes here?
NO3
We have
plus
molecular
H2O. So
Versus how
this
many
would be
of them
the
there are. So at
total
one of
ionic
these
or something like that, total
temperatures,
ionic.
Right.
the variation
so total
in
ionic
molecular
and spectator
speed.
ions.
Well, no, that's a bad way of saying it.
So you get
Molecular
CS
speed is
crosses
more
out CS.
consistent
NO3 and NO3, so you end
for
up getting
various different, because the
like
molecular speed
CS.
stays about
Yeah.
the same
and
clump over here.
NO3, and then
While the
it's
relative
net
number
ionic,
of molecules
Mhm.
is
Alright.
really different. Goes
and
all the way
then
up
you
and all the way
get
down. Whereas here,
So is this saying that
OH
there's
plus
more
H
molecules
equals
when
H2O
when there's less
is the
speed?
net ionic, right?
Right.
what it's saying is that
Already.
The only
Or is this like
one
with
thing
the
you should
with
remember
the arrangement?
is, well, what might be
what this
one thing
appears
we're
to be
forgetting with
telling me
these.
is that here, where there's a ton
These?
of molecules, or no, wait a
You
minute.
started to use it, and then halfway through.
AQ.
Or maybe I'm imagining this different. Or is it more like there's a
Do you
given
need to-
number of,
He said something about like you don't need to include the
this is
charges on
probably
the
what it
product
is.
side,
So
just the
say
reactant side.
I have,
Is that
100
true or?
individual molecules of helium in this particular
You-
container.
Well,
Then
not in like the main
at,
reaction,
um,
but in the ionic.
this
reactions, you
temperature,
do
the
need
temperature
to
represented by
include the
this
charges.
Yeah,
curve,
for the
then
ions,
a lot of those
because
molecules
ions are atoms that have charges.
will be going at
Okay.
a
So
fairly
you know,
slow
water
speed,
doesn't
and
really
not
have
very
a charge
many
on
of
its
them will
own.
be at a high
So it'd
speed.
be like if
I think that's what they're going for. 'Cause so then I don't put more molecules in the container for this
like
one.
if for whatever
for this
reason
one, I have those same 100
K would
molecules
instead
in
of
that
having
same
plus 1 be
container,
plus 2, you'd
but
have
at
to
this
include
other
that
temperature,
because it'd be
There's
K
more
ion
of
instead
them.
of
there's
K
more
atom.
variation.
Faster.
Like these are 2 of my, and one of them's going
that what you're
this
talking
fast,
about,
and one of
or-
them's like,
No, because
makes
would
sense.
whereas over here they're
K
just
ever
kind of
have
both
like a
really
negative
fast.
2 charge?
That makes
No,
sense.
but there was
So
something that we were
then
talking about
it
in
would-
our lab that was
See, then it would
magnesium
seem like
ion
this
is like Mg2
was the lower
plus
temperature though.
compared to
Yeah,
regular
this is lower
magnesium.
It
temperature.
is.
I
Okay.
So
think-
I was
Oh,
I was
right.
using that as
I'm
just
pretty
the
sure
first
this
thing I
was lower
saw.
temperature, 'cause
Yeah.
I was really
Well, I think what they
confused.
mean
Because we'd have to
there
look at the
is
book, I guess.
like if you say
or
just
your notes.
Mg, you're
I'm
just
pretty
talking
sure
about
this. I'm like
the atom
100% sure.
as like a concept. You know,
And
if you
then
have it in
I'm pretty sure this is wrong too.
a
Represents the gas at the
compound,
higher.
you don't have
this
to
is
write the
higher
charges or
temperature.
anything.
Okay.
And
But
this
when it's specifically an
temperature
ion,
equates
like
into
here it's
kinetic
dissociated in
Doesn't it?
water,
Kind of.
and you're talking about it by
So-
They're
itself,
related to each
then
other.
you need to
So
specify
this one would
the
have more
charge.
kinetic energy,
Alrighty,
which I'm pretty
so
sure this was supposed to be.
NO3 would be negative, CS would be
Yeah.
plus, that would be
Okay,
negative,
so which
that'd be
curve is
plus.
consistent with a higher
And then
diffusion rate?
You wouldn't do
I don't
anything to
know.
H2O,
I
right?
think the answer
is
Just
two.
leave it.
But I don't know
Alright.
why.
I
And
would
now
say
I
that
have
as well.
calcium
Because if we're talking about diffusion, we're
hydroxide
talking
and
about
acetic acid.
Like breaking through. Like
or becoming less concentrated, and to go from a place
Anyway,
of because matter
calcium,
will always naturally
Ca.
go from a place of high concentration to
To
low
low
concentration. That's going to happen no matter what you do, but it'll happen faster if they're
Ca.
moving faster, which they appear to be in this one.
which makes sense.
Hydroxide.
So now we come to this
so,
though.
OH, but Ca is
Which we might just need the
2, so you
equation.
need 2 OHs.
Yeah.
Mm-hmm. And because it's 2 OH.
I guess, or you can.
It's a -1 charge, so having 2
I
leads to a
tried
-2
and I
charge.
got battery.
Right. And just to
voltage, and
like
that's not what
as a
we're talking
detail
about
thing
here.
to show that both oxygen and hydrogen.
I don't know.
There's 2 of both of them.
We might have to steal your.
So would you put it in front of
I
them?
don't know.
In front of it, or
Can we-
No.
or parentheses?
Like you're fine. Yeah, parentheses.
So if you find the equation,
Boom.
I'll be right back.
Yeah.
Okay.
What's that terrible
Because I think
parenthesis?
you'll see in like the examples when they actually give you the formula, the OH is usually in parentheses.
Okay.
Not this.
And you have, like, so you got the calcium hydroxide and acetic acid.
Oh yeah.
I use the activity
Is
series, so if like
Acetic
NIPD
acid based off of like
So what am I looking at
is like
to see if there's
acetate
spontaneous
that, so it'd be
analysis?
C2H3O2.
That sounds right.
As
No
I say,
one else is coming
that's
with a
another thing I
question.
started memorizing.
Yeah, that's really good.
So
remember this.
but
Because the hint it says.
so it'd be
Oh, well,
wouldn't-
that wasn't it. When I pushed charge.
in this case would it be C2H4 since it has to have another hydrogen to make it acidic, or
Yeah, but in this case, you would just add another hydrogen at the beginning.
It says when it's like it will be reactive.
That's
it's not.
usually just how you write acids to
It
signify
says
like
the opposite.
if they
That it's
lose
not-
a hydrogen,
okay.
it's like the first one.
okay. So
It's
H,
just kind of a naming
H.
scheme thing.
What did I say?
I looked them all.
C2H3O2.
Yeah, because these H's are in
So they have
like
to be next to each other.
the
Like
acetate,
if they're high,
like
but what if one's high,
compound.
one's low.
Okay.
and it's the extra
Like
H
is
that makes
in
it
the
an
case
acid.
with
Would that have
silver
anything to
and
do with like the
chromium,
H
one of
bonding to something else like separately?
Like
So you have like
silver-
2 C's instead of having
silver's
like
way low.
And then
4
since
hydrogens
silver
bonded to
would be
either C2 or
non, like, it's the
O2. You'd
least
have this one
reactive, so it
But
doesn't
then
only
where's
on
chromium
C2.
that it's going with?
Yeah.
Yeah, so that's one of those
Okay.
where they're really not all that
Anyway,
close to each other.
this is gonna be another one of those H2O problems. So I'm fairly certain I already know the answer.
Fe and Cr are right next to each
Yeah,
other.
most acid-based ones will be like that.
But anyway, you got
They appear to be at the top half.
Jesus, CA. I should probably include that.
So let me see the ones that you
a
already
negative one,
tried,
that's a positive
I
one.
guess. Let's see
So
what
you got
we
CA,
The Ni with spontaneous.
C2H3O2. That's
I thought maybe Eg
plus
was
2
somewhere in
plus.
F.
And
I don't know,
this
maybe I mixed
is
them
a
up.
negative, so you'd have
And a
to
third, I don't know why I didn't look. I didn't know you could look back on incorrect until the day. So.
plus
Okay.
H2O.
So this is like the same as.
Yeah, it's the first one I did.
Okay, so there's.
So I don't know if I'm getting if
total
those are supposed to be on
ionic
that side, but then Ag is not the same at all to FeC. Or
equals
because NiPD
CA, so A clear.
NiPD are towards each other but lower. But I don't know if that matters. So is it Ag's just
I'm trying to remember, like,
CA.
to reason this out though,
plus
we have to go back to like
OH.
what activity series even means. Like, did your professor?
How do you know when to put a 2 at the beginning or the end of it? Like, it's like
Does it mean that they donate
compared to putting a 2 there to a big 2
What
right
does it
here.
mean?
Does it matter?
Yeah, it does.
like everything they go through?
In this
if
case,
he
you would
doesn't
have
go
to
through
put
it,
it
he goes through
at the
things.
bottom because the O and the H are together.
Is it
Okay.
anywhere
But
in here?
usually if you have an
This activity
ion,
series
you would
stuff.
put it
I think it would be
in the front.
Okay.
Because,
I'll let you listen.
like, let's say there are 2 cesiums.
That would help.
When it dissociates, like, they're apart. They're totally separate.
Okay.
But if they were together in the molecule, then they're bonded to each other. That's when you would use this smaller 2.
Okay.
but when they're totally separate, then you have to put the 2 in front.
So for sake of argument, if I were to put a 2 right there, I'd have 2 oxygens and 2 separate hydrogens. I wouldn't have 2 OHs. You know what I mean?
Actually, you just
Here
have
we
2
go.
oxygens because if you put the 2 there, that just
I thought
no,
if you put
actually,
it in front,
you're right.
Okay, so okay.
Yeah.
So to signify that they're together, you have to put it at the end.
And what else do you need?
The charge.
And what else?
Oh Jesus.
Your numbers are good. Just
Parenthesis.
remember, yeah. Just to clarify that both the oxygen and the hydrogen have 2.
I think there's
Okay. So plus H plus C2H3O2 negative positive over here to CA
Because this is talking about in terms of like displacing
plus
hydrogen gas.
Okay.
C2H3O2 plus C2
GG.
plus H2O. And so we got you cancel, which leaves OH and H and H2O. So you got spectators. I should list for spectators equal or are CA plus 2 and C2
Okay.
H3O2.
So this must at least have something to do with how good they are at donating electrons. Because like here, it takes these H pluses and it gets rid of their charge, and then it ends up having a positive charge. So it must have shoved electrons in it.
H2O.
And this probably had to do a similar thing here, because it ends up having lost electrons and shoving them onto there. So, that's part of what this is. So, then, if we're thinking about this in terms of
Stuff on the table.
affinity for electrons,
So like now I just
Then
want to
the
go through
only
those
time that
Homer problems
something
because
kind
like
of like
I've
you were
never been able to
talking about,
understand
whether they're
the
close to each
sample
other or
problems. So the Homer problems are obviously harder than the sample
Yeah.
problems. So now that I actually am understanding it, I want to try to test my
the
knowledge
only
a tiny
ones that
bit
should be
more.
really spontaneous are the ones where they're really far apart. But that's what you
For
already
which
tried, isn't it?
concept?
Is the one where you already tried
Like the
that.
test review you're going over?
Yes.
AG.
Hold on, there was a problem I
That's
saw.
pretty far apart, relatively speaking.
and then the
There we go.
FECR.
That's close, so that should be non-spontaneous. So let's write this down.
It would be
FE.
I wanna- is there-
CR should be no.
yeah. An acid-base reaction that's not like with
NIPV should be
H2O
no.
is I want to try and see if I can't get one of those, or is that always going to be with H2O?
So let's see if you've already done this combination. NIPV should be no, and then AG and CR should be a
Yeah,
yes.
I'm not
Okay,
sure
answer my
in
question.
160. I think
No, I tried it with.
I've seen maybe one problem without the H2O, but that was on like
Okay,
our
so
group
that-
study guide.
Okay.
So that might be different than the book.
So that one right there, 4.25. I was looking for you.
Wait. So
So
AG and CR.
Yeah.
AG and CR. Okay.
These wouldn't
And
be
one more.
acid base though.
how many kilograms do
So would it still be the same rules apply though?
Yeah.
So just I feel like I slightly cheated on the other ones just because I knew that H2O was going to be the spectator and I
Yeah.
could figure that out. So I mean I want to try
Wait a
at least the
minute.
first one just to
Okay.
see if I can
They might
actually
have.
use the
They
rules
might
rather
want
than
you
Yeah,
to
just
sure, that's good.
Because which one?
flip it over. Yeah,
Okay.
4.25.
Shoot, I should have.
Oh geez.
Which one's the more active? Oh, that.
So is that
CR
saying
is
right
more
there that
active,
those
right?
aren't balanced, or are those
Well,
balanced
then it
based
doesn't
on the
make sense that
problem?
it's the one that ends up losing electrons.
kilograms?
It says right a balanced molecular.
Well, is this even a full equation yet?
Oh no, it's not. That's a good point. Good solid point. So you got CaCl2 plus
Mm-hmm.
So is it
I feel like if
opposite?
they wanted you to answer a question like this, they needed to give you more information.
So you got CaPO4, which is a -3,
This is starting to get into other stuff.
and that's a cesium back to being a +1. So okay, so it's already balanced. At least that's how
This
it
one
is.
I'm gonna try it.
Plus
So first we'll have to figure out what the solid precipitate is, so we'll have to write the
CS
equation, but
So
before
that'd
we
be
start
fine by
that, we have to
itself,
think about
CS,
what the
CL.
formula for mercury 2
Because
chlorate
it's
is
negative
going to be.
Okay, so
So
that's
mercury
-3
2 is indicating to us that it's,
calcium.
well, you probably know. What would be the ions
calcium's
that would be
2.
mercury 2?
Mhm.
So
Represent that. Like what the charge would be on it.
So we do
you'd need
Hg.
3 of these and 2 of those.
Right.
And then
So,
chlorate is that
two.
C.
3. Actually,
No, that's right.
yeah. 3.
You don't
So you're
really
causing
need a
those
parentheses
smaller
because
stuff.
it's just calcium.
Yeah.
Because we have to study these.
It won't hurt,
before
though.
the test and
So anyway,
test them
you
next
have
grade. So chlorate. It's not
group 2 is
ClO,
always soluble.
Is
Just
it
always
balanced yet?
dissociate. Oh.
You have the charges
So
balanced.
we have
but
so we have 3
I'll have to
CL
check
or
this.
3 CAs over here.
Hey, I
So we
did this
need
one right.
3 of them over here,
I'm
which
pretty
gives
sure
us
it's,
6 CLs.
ClO3 minus, but we should check that.
6, so 2,
So it should be balanced.
and now it's balanced. So, goodness gracious, that's a little messy. But anyway,
Or I just put chlorate. wouldn't
Yeah,
it?
chlorate.
group 2 always
Google will switch it
dissociates,
back.
so you have would it be 3Ca plus 3 3Cl2?
ClO3 minus, yep. Okay.
Since you
For
have
what?
3 that goes
So
across both of
then,
them. That 3 right there.
if you also
Or
wanna
would you
check
just
mercury too,
yeah, it'd be 3Ca, but what?
I think that'll be
Or-
Hg2 plus.
well, I said 3Cl2 would be 6Cl, right?
Right.
Alright. 3Ca plus 6Cl plus cesium always dissociates.
Yeah, so mercury 2
So it would
oxide
be
HgO.
6Cs plus
So our formula.
would it be 2PO4 since PO is a polyatomic ion,
Is that on the bottom?
or
chlorate?
would it be
When it says
8PO?
HCl.
I'm assuming it'd be
So
2PO4
first let's write our two
Right.
ions. So
And
we
why
don't
wouldn't
confuse
it be,
ourselves, I guess. So just write
eight?
because you have to know that the P and O are
mercury 2
together.
and the
So
ClO3 minus.
it's like it's a polyatomic
Yeah.
ion rather
Like
than just
that?
an
Right.
element.
And what's the 4 referring to?
The 4 is
So then
referring to
it'd
how
be
many
up
POs there are.
So
Right.
it's
Is it-
ClO3.
POs or
Oh,
is
okay.
it,
So much for your help.
Okay.
Yeah.
does it refer to the
Might be
whole
back
thing
tomorrow,
or does it
Alright,
refer to
this
one
will
of
be
the
great.
elements?
Have a good night.
It just refers to the my bad. The oxygen. So you'd have plus 2PO4
So that would be the whole formula when it's put together. I mean,
equals, so we
I don't have
have
to do that, don't worry.
3Ca again.
so then for making, now I have to write out the whole reaction, right?
2PO4
So then you do it this way, right?
plus, and I'm gonna go
So
back and write
then-
aqueous after I get this all
You don't
written out.
necessarily have to write out like the total ionic equation.
Plus,
It's just you now have to see what it reacted with. So it reacted completely with a solution containing 13.180 grams of sodium.
all of them are
bicarbonate.
spectator ions,
So
aren't
now we have to write
they?
out
Because
the
there's at least one of them in group 2 all the way, so all of them
Chlorate
dissociate.
is CrO4, and then is it 2?
This is dichromate,
Let me finish writing that out really
which
quick.
I think is Cr207.
CS plus 6Cl.
I think it's minus.
But no, like you have calcium, cesium,
And
calcium, cesium, all of which are in group 2,
Cr2O7
and
must
the
be
rule
joined.
says that if it's in group 2, it's always
If it
soluble.
requires 2 Ks.
So that means
Okay,
all of
And
them are
then what's
spectator
that?
ions.
Potassium. Okay.
Correct.
Right, and what would happen?
So Cr2O7.
What can you just write down for your answer?
Honest, I'd just be like no reaction.
Exactly.
So,
Which that's a
spectator.
plus 2 sodium, is it?
Or
Is
you
it
don't even
on-
have to write all that out.
Alright, so just no
Sunflower.
reaction.
Yeah, if you just if you write the balance equation and you look at it and you think, oh, it's all aqueous, you can just write no reaction.
Alrighty. And
Okay, so
they.
do I put it
That's
together
gonna be
right
something
now?
different.
Yep, so now we put it together.
Na.
Figure out.
No, Na. And. Where's the N?
So now we can write our balanced equations because now we have both of our reactants.
Right there. I'm not quite
So,
sure on the
when I'm
rules
doing
for
this though,
the
it's
transition
not, it's
metals.
this part, right?
So I
when
guess that'd
balancing
be.
it. Because I don't
something to
think
work
I've
on.
ever seen that.
So you got Na.
Well, it depends
2S
on, I guess, which one you're
plus
trying to do. If you're trying to figure out what your
Zn
precipitate is,
SO4
Then you just
then you need to use your
over
ions
to
because you're gonna need to like
and
see
sodium
that this
sulfate.
Na is gonna end up with this, so that's gonna be soluble.
Na
So that's not gonna be your precipitate. It's gonna be the
plus
mercury dichromate. That's gonna be your precipitate. So that I figure out from the ions.
Z
If I'm
zinc gas.
balancing this though, then I kind of need these because I need to know that there's 2 sodiums.
Aren't like
for
most of the
every
transition
one
metals
of
like
this.
there's like a stair step
And
right here or
this
something like
shows
that?
me
Like
whereas
aren't
this really doesn't.
these typically a +2 charge?
so when that's
Typically,
balanced,
but you
though,
can't
like,
rely on that.
Or you
Yeah.
could.
So how would
like,
you be able to figure that out? Because every teacher I've ever had says, "Oh, transition metals are a tricky thing." So I mean, and then they don't go any more in depth.
They're right. Well, in this
Like I
case, because
could
they don't clarify,
also
you
write
need to look at
this
the charges
as,
of
like,
the
H2
other molecule to figure out what the charge is.
Okay, so in this case, zinc or SO4. Is that negative
Like,
two charge?
is this kind of
That's
more what you were talking about?
memorization. I don't.
Plus
So it is negative 2.
2
Um,
and
That sounds right to me, but
Might as well double check.
plus
yeah.
a single.
431.
Because I'm not always here to be like, that sounds right.
Yeah.
Minus, you could also do that.
What was
okay,
it?
and then I put the
SO4.
I put them together. Like, do I need that in this one, or put that with that, and then the
So it's gonna be
SO
H.
SO4 is negative 2.
these are all
Yep.
aqueous.
So in this case is yeah, that would have to be a +2 and that'd be a negative 2. So that means yeah, I should probably write these down first. That'd be +1 and this would be -2
these
2 of
from.
the
Oh, because the two. Okay.
and so
So
zinc in this
then-
case would be yeah. So this would be it'd be fine. This one was over here, so
Oh,
that'd be
but that's but they're cancel out.
+2. S is -2. That is -2. Sodium is. So we need another one of
It'd be
those
NaClO3.
because sodium's a
Or what do you do
+1.
with that part?
And
The
then
CO and R, can you leave that
so sodium is
full.
in group A, so that associates
Or
Na.
actually, would that be soluble or insoluble? We should ask.
2
What
Na
did we decide?
plus
together?
S
So that would be soluble. Or
plus-
yeah, because
So
they're
you
Na.
could leave it dissociated.
So that
plus
together?
Yeah. So what I would write is something like, if we're writing a complete ionic equation.
I don't
which is
remember
gonna
rules
be-
based on transition metals.
And this is that
Um,
solid. And
I
then
think there's a rule that says
plus
like all
my same
like
2 sodiums.
Oh, because one has to be.
it's like all
same 2 chlorides.
sulfates, chlorates, and all that stuff is
'Cause then if
dissociable
you were
unless it
gonna
has
do
like a
that
certain
ionic equation,
thing.
you just go
Mm.
I can't remember what those certain things are.
Those are usually transition metals, but you still have to memorize
then-
which ones,
Which ones?
unfortunately.
So this
So how am I putting those
So,
grams, both of them together? Are they separate, like all these separate equations?
I spelled sulfates wrong in my notes. That's disappointing.
Specifically?
So all common sulfate are soluble except with CaSrBa. So that is not one of them. So that's fully dissociates.
See, what sucks is that this is a limiting reactant
Plus
problem on top of everything else.
SO4.
So, like, you have to figure out which of those is limiting. And to do that, you have to figure out how
same
many
concept. So
moles
Na.
of this each one of
Um,
forms.
2Na.
The good thing is that by
S
finding the limiting reactant,
O4.
you'll, like, through that process,
Plus.
figure out how many
This
moles
would
of
have
this
to.
you produce. And then you
No,
can just
wait,
easily
um,
turn that into grams of precipitate.
Okay, so this is limiting reactant, because then it asks for excess at the end.
So that's.
Yeah.
Is that like just-
Yep. Yeah, so that's like the standard follow-up question for the limiting reactant.
Based on the fact that I cannot think of a rule that would make it dissociate, would that mean it wouldn't dissociate, seeing as how none of them are in group 7A, 1A, or in 2A, or they're not like fluoride or anything?
Yeah, that's a good educated guess. I would double check your rules just to make sure there's nothing about.
Alrighty, so all common metal hydroxides, zinc is a metal, but it's not hydroxide, so all
The limiting reaction stuff be here, or might that be the previous chart?
are sulfides. So all common sulfides are insoluble except those of group 1A and group 2A ammonium. So that doesn't dissociate because zinc is not in either of those, any of those.
Right.
So you get ZnS.
This
And that
is
means
chapter,
that where'd you go?
oxidation.
Na would cross out,
What have it been before that?
SO4 would cross out,
I
so
almost feel like limiting reaction stuff.
steric ion BNA
This is
Well, we can.
plus
I can
and
give you the one little thing that you have.
SO4 minus 3. And then net ionic would be
So,
just S plus
do you
I don't like
remember
doing it that way. ZN plus S because that's what's gonna come
anyone
first.
ever talk to you
Equals ZNS.
do this thing,
And
the
that
grams to
is
moles
a,
to moles to grams bridge type of a deal?
-2.
So the idea is that you have this one substance, and then you go to moles of that same substance, then you use your balanced equation
and that would be your final answer, right?
to get to
Yep.
moles of the second
Alrighty.
substance.
So I think I'm good on. I got that semi down, and now I wanted
So in
to.
this case,
Weak acids and weak bases.
I
Heat.
think we're good to stop.